Finally, as part of this session, we are going to understand the difference between graph and plan. We could have done it earlier, but like we have now a fair understanding of the plan, conductivity, and also the batch graph and continuous graph. So now we can make the difference very clear, and between graph and plans. Okay, so the first, the obvious difference is graph is a smaller unit of plan basically. So we could have many more graphs running in a controlled manner, in sequential manner, or in a systematic manner within the plan, right? That's when we have a plan. So and if we look at the construct of the plan, so like we have a we have a components in graphs. Similarly, we have a let's say we have task in a plan. So this is kind of maybe a difference. And we have ports. Like if you look at this is a graph and this is a plan. So if you look at this picture, okay. So this is the input file, and there is a component, another component, and then there is a downstream processing. This is output file. Then there is lower flow which are running. So we call and here we have a plan like a program task, then conditional task, and there is a graph task. So to connect, the obvious, the visible difference between construction of the graph is like we have a connection point in plans like this is output connection point of the plan task, and this is the input connection point of the conditional task, and this is failure connection point. This is a output connection point. Similarly, we have ports in this graph. So this is a input port of the this component, and this is output port of this input file, and this is input port of this component. And likewise, we have ports in graphs, and we have so this the connections, right, using the flows. So these flows, right, so they are indicate the data flow, basically actual physical data flow. But these here is the control flow, right? So, I have indicated in this one. So these flows are data flow. Basically, the data itself flows using these, flows basically. But so within plan, these are the control flow. The control passes from one task to another using these flows or in this sequence, this visible sequence, right? Basically, and okay. Okay, so I have. So let's jump on to this one, the actual kind of difference. So the parameter evaluation difference. So we have understood the parameter evaluation in a graphs, and parameter evaluation in conductivity and in plans as well. So based on that, we can say that there is a kind of minor or some difference between the evaluation of the parameter and passing of the parameters, from one graph task to another. So there is no way of passing the parameter from one component to another, but there is a way to pass the parameter value from one graph task to another. The dynamic. So the recovery of the graph, because the graph is in a single piece unit of execution. So we know that there are different recovery mechanism in graph, base graph and continuous graph that we understood already. But there is a difference between graphs recovery and the plans recovery. We have a rollback method, and so mostly the recovery is in our control basically in a plan. So in that way, we have a upper hand, in terms of recovery in the plan. And then there is a shutdown. The shutdown, there is no mechanism shutting down the batch graph. If we try to compare it with the continuous flow graphs, so there is a different shutting down mechanism in a continuous graph. If you shut down that, then it's a complete stop of the execution. But if you shut down the plant, then it will wait for the currently running perform task, okay, performing method, and then only it will be shutting down softly. So if we try to shut down the plant, and whenever we restart the plant, then it will start from the that place only. you know so this is how shutdown works in plant. But in continuous graph, if we restart the shutdown graph, then it is a start from the fresh. Okay, so this is the difference. Okay, again, then there is a difference, this differentiation in disabled task or components. So let's jump again onto the picture actually. So let's see. I mean, if we try to disable this, let's say, these components, right? So this is not going to be kind of executed. So this is complete disable. This is not going, and the control will be passed. I mean, the flow will be data flow will be passed from skip this component basically. If we disable it, disable in the sense of we can right click and disable in the GDE, not using the conditional task basically. So I'm just disabling it. So this component is going to be skipped if we disable it. But there is a different here in uh, you know so there is a difference over here in a plan in plants basically. So if you look at this picture, let me make it kind of smaller. So okay, so so let's say we talk about the number one, first one. There is a task T1, and then there is a task T3, and in between there is a task T2, and this is a program task, and we are going to disable it. Right click and disable it. So this is kind of short circuit, right? In terms of if you talk about the plans, so the task T1 is going to be executed, and then the task T3 is going to be executed. There is nothing is this is a simple one. So task T2, is not going to be executed. It's not going to be a uh, you know active. Okay, but if you look at the picture, the below picture, like we have T1, we have T2, T3, T4, T5. Okay, see these are, and there's a conditional task, false, conditional task, false too. Okay, so let's talk about first. I mean, the first scenarios wherein we do not have any disabled components, disabled tasks basically. So the T1 is going to be executed, and then then T4 is going to be executed. Okay, T3 is going to be executed, and the conditional task, this conditional task below one is going to be executed, and control will pass to the failure side. This flow, right? This flow is not going to be active. And similarly, this because it's a false condition in this conditional task upper one, the control is going to come onto the failure connection point, and T4 is going to be executed, and T5 is going to be executed because what we have specified, enabled branches required to run task is any. If any of the branch of task T5 is active, then this task is going to be executed. If we have O and, then there is a different case. This is going to be fail. Okay. So if you let's talk about this feature actually. If we look at any tasks, we can right click on it, and if you go to the properties, parameters, then there is a parameters called enabled branches required to run task any or all. Okay. If we say that all the upstream branches are should be active, only then T5 is going to execute. Then it requires both the. Otherwise, if it is any, then any of one can be active or both can be active. This is and or logic basically while designing the conductivity. Okay, complete conductivity. Okay. Now, Let's what we can do is um, let's make the T4 as a this one, disable it T4. So what is going to happen if we disable T4? So the complete, things of execution, control, forcing, and everything is going to be changed in drastic way, because if T4 is not going to executed, I mean disabled, then T2 is not going to execute, T4 is not going to execute, and T5 is also not going to. Only thing is T1 and T3 is going to be executed, and this conditional task is going to be executed, because the this CT1, the CT upper one, is going to be end up in false condition, and control try to come here, but this is disabled. Therefore, this branch is disabled, and therefore this T5 is not going to execute. This is already disabled because of false condition, and this control is going to the below failure connection point. So this is T5 is not going to execute, and T2 already is not in execution, right? So only T1 and T3 is going to be executed. So it's not, it's a different, disabling component and disabling the any task is very, very different here. So, okay, so let's assume that if T4 is, or let's assume that T2 is, T5 is at the failure connection point of T2, right? And if we disable the T5, so this is kind of another, another design basically. So because we cannot recover, this is going to be failed design, because the failure point of T5, right? So if anything failure happens, the T5 is trying to execute the T5, T2 is trying to execute the T5, but T5 is not, T5 is disabled. So therefore, the recovery is not going to happen. So because we have taken the recovery in our hand, right, while connecting the failure method to the T2, right, we have kind of taken the recovery into the our hand, right? So in those circumstances, what we can do is we need to remove this connection. Actually, if we want to disable the T5, we need to remove the corresponding connection, so that the adverse effect of a complete, complete execution unit is not going to be altered in any adverse way. So that we need to take care, okay, while designing this such kind of such kind of graphs, or such kind of plans. Thank you so much.